Now, most of the time, we're going to construct brute force solutions ourselves. We're going to write the code as we did with the coin problem. However, if you're solving a mathematical function, there's also a tool called scipy.optimize.brute, which can be used to find a brute force solution to a function of one or more variables. Brute evaluates the function across a grid of points, which means, though, that it can miss fine details. Here we're going to examine a particular problem, 10 plus x squared minus 10 cosine of 2 pi x. First, let's plot it and see what this looks like. It looks a lot like that bumpy convex function that we saw a moment ago. Now, most of these functions, like scipy.optimize.brute, actually search for minima, not for maxima. We import scipy.optimize.brute, we apply it to a function, and we give it a range to search for the value within that function. So it gives us out a value, negative 1.989, and this describes the point at which it found a minimum. Now, if we examine our function, we can see that negative 2, which is essentially what that answer was, is a local minimum, but whatever set of points that it scanned across this entire system here, it missed the actual true minimum at 0. We can increase the number of points that it uses by passing in an optional ns argument. And in this case, increasing ns to 25 yields us the true answer, which is that the global minimum occurs at 0. Brute is useful for small domains, as mentioned before, for other kinds of brute force solvers. And you may have to try a few different ns values to get a fine enough grid to give you the information you're looking for.